In this video, we're going to find some unknowns of a trig function after transformation. A and b are constants. A is in the function, here, and b is positioned on the x-axis in the figure, here. We need to find the values. The figure shows the graph of y equal a times sine of 2x degrees. So what steps can we use to solve this problem? First and foremost, we should be aware that this function can be transformed from y equals sine of x degrees. We should be able to draw the graph of y equals sine of x degrees, then compare it with the given graph of y equal a sine of 2x degrees, including its shape, maximum value, and period, to determine the transformations that have undergone. Then we should be able to find a. With a found, b can also be found. So this is the graph of y equals sine of x degrees. What's the first thing you notice? Do you see that this graph and the given graph are in different directions? So let's try to reflect the graph of y equals sine of x degrees. Actually, it's the same whether it's reflected with respect to the x-axis or the y-axis. But as we have the unknown a here, let's reflect the graph with respect to the x-axis to make it become y equal negative sine of x degrees, so that except for specific x degrees, where y will be equal to 0, the value of y will be reversed. Okay, by now we know that a is a multiple of -1, so what's the multiple? We know that the maximum value of y equal negative sine of x degrees is 1. Look at the given function. There is not any addition or subtraction of the function to shift the graph vertically. Then look at the given graph. The maximum value is 1, which is the same as y equal negative sine of x degrees. So the graph is not enlarged or reduced along the y-axis, and thus the change in the value of y is only due to the reflection. That said, we can determine that a is equal to -1. And the given function is y equal negative sine of 2x degrees. Let's draw the graph of y equal negative sine of 2x degrees. The graph is reduced to 1/2 of the original along the x-axis. The period thus changes from 360 degrees to 180 degrees. The point at which the graph reaches the 1 will be when x is equal to half of 270 degrees. That is 135 degrees. So b is equal to 135. In conclusion, the graph of y equals sine of x degrees is reflected with respect to the x-axis to become the graph of y equal negative sine of x degrees. And then the resulting graph is reduced to 1/2 of the original along the x-axis to become the graph of y equal negative sine of 2x degrees. That is the given graph. Therefore, a is equal to -1. We can put b1 into the function obtained. Negative sine of 2b degrees is equal to 1. We can still find b is equal to 135. That's it.